Hello everybody. So in this question, the number of radioactive atoms N in a sample of a sodium isotope after time t hours can be modeled by N equals NO e to the power minus KT, where NO is the initial number of radioactive atoms in the sample and K is a positive constant. The model remains valid for large numbers of atoms. And the part being solved is A part says it takes 15.9 hours for half of the sodium atoms to decay. Determine the number of days required for at least 90% of the number of atoms in the original sample to decay. And then 5b is telling us find the percentage of atoms remaining after the first week. Give your answer to two significant figures. 5c, explain why the model can only provide an estimate for the number of remaining atoms. And D is saying explain why the model is invalid in the long run. So then to work this bit out, we need to first find out the value of this constant. So that is K. So then it takes 15.9 hours for half of the sodium atoms to decay. So what that means is if half of it is decaying, you see NO, N is less than NO. Okay, that's giving it a negative power. So N is less than NO. So N would be equal to half of NO. So then I can write half of NO is equal to NO times e to the power minus K times that's 15.9. So then cancelling NO, I can write half equals e to the power minus 15.9 K. And then I can write this as 1 over e to the power 15.9 K. And then I can write 15 cross multiplying e to the power 15.9 K is equal to 2. And then I can take logarithm of both sides. So taking logarithm of both sides or on both sides, we will have log to the base e to the power 15.9 K is equal to log to the base e2. So therefore log to the base e is 1. So 15.9 K is equal to log 2. So therefore K is equal to log 2 over 15.9. So that will give me, if I were to do a bit of approximation, that K is equal to 0.044. So if K is equal to 0.044, therefore the equation can be rewritten as N equals NO multiplied by e to the power minus KT, so minus 0.044 times T. So this is the equation. Now we need to work out the next part. Let me just highlight it a little bit so we know it stands out. So then I have to work out for 15.9 hours of this bit, the 90%. So number of days required for at least 90% of the number of atoms in the original sample to decay. So 90% means 90% has decayed. So I can write 90% has decayed. So remaining would be 10%. Therefore, N would be 10% of NO, that is equal to 0.1 NO. So I can write 0.1 NO is equal to NO e to the power minus 0.044 times T. So the NO cancels out, and therefore I can write 0.1 equals e to the power minus 0.044 T. So once again I am going to write 0.1 is 1 over 10, and that is equal to 1 over e to the power 0.044 T. Therefore e to the power 0.044 T is equal to 10. So again we need to take the logarithm of both sides. Taking both sides, I will get is equal to, okay, then log to the base e is 1, so 0.044 T is ln 10. Therefore T is equal to ln 10 over 0.44, and that will give me 52.33 hours. So if T is this, and that is equal to, if I divide it by 24, then I would get 52. So if I say and that gives me 2.2 days. So that's the answer. T is equal to 2.2 days. So this is my answer bit. Right? So that's the first bit done. So now the second part is asking me find the percentage of atoms remaining after the first week. So when they say first week, that's 1 week. That is 7 times 24, and that is 168 hours. So T is in hours, so therefore I'm going to do that. And suppose the number of atoms remaining, or the percentage of atoms remaining, not number, wrong thing to say for atoms. So the percentage is, suppose X% is remaining. Therefore, x over 100, 0.0x times NO is equal to NO times e to the power minus, as the equation, 0.044 times T. So e to the power minus 0.044 times T here is 168. So I can find out what that is, 168 times 0.044, and I will get that. I will cancel out the NO, and I can then write, therefore 0.0x is equal to e to the power minus 7.392. And if I multiply it all by 100, therefore x would be equal to 100 times e to the power minus 7.392. And if you do that, you get x equals 0.0616. So that is equal to 0.0616, and so on. So This is the percentage. We've been asked to do significant figures. So therefore, x is equal to 0.06%. So this is the percentage of atoms remaining. So then I can just, this is the answer. Okay, so the next bit of the question, we need to do a little bit of writing. Explain why the model can only provide an estimate for the number of remaining atoms. So the answer to that is the model is continuous. The model is continuous, but the number of atoms is discrete. So only number of atoms remaining can be found out. Okay, so then for the next bit, explain why the model is invalid in the long run. That is because as the numbers get larger, as t gets large, the number of atoms predicted by the model gets smaller and smaller, and so the model is no longer accurate. So as t gets larger, because we are approximating, okay, so as t or time, so if we say time, the t gets larger, the number of atoms predicted by the model gets smaller, and so is no longer accurate. Okay, so that is the answer to this, and that concludes this question.